This is Thermal Runaway at its finest. We might have added some accelerant for the intro, but I promise this printer actually doesn't have Thermal Runaway protection. Let's talk about it. What you're about to see is a test of Thermal Runaway. It didn't exactly go as planned, but we made it go as planned. We're going to talk about the findings at the end of the video, so make sure you guys stay tuned. But let's go head outside, let's run some extension cords, run some batteries, and let's put a 3D printer to the test that I know does not have Thermal Runaway protection. Let's get into it. Thermal Runaway, something that every 3D printer should come with stock, is something that, well, they don't. Some definitely don't, and ages ago, these were 2014, 2015 vintage, did not. It was just not a thing that printers came with. And I want to show you guys what happens when you don't have Thermal Runaway enabled. Let's talk about what we've done here. I've actually already filmed this video once before, and unfortunately it didn't work. We had way too much issues with the breeze out here. But what I've done to kind of help stack the deck in my favor is I've went ahead and removed the extruder. Now, by the way, Creality fanboys, does that look familiar to you? Yeah, this is almost 10 years old now. The heat sink for the extruder, gross, as well as disabled the fan. We have also taken off the thermistor, which will not allow the printer to know what temperature it's at. Now, I had this thing running full bore for over an hour. We'll have the footage on screen so you guys can see what it looked like, but suffice to say, it smoked, it got hot, but nothing really happened, and I'm determined to watch this thing catch fire, so let's go ahead and turn it on. Now, this printer has not been modified on its firmware. This is actually how it came from the factory, which should scare you, but it doesn't scare me. Hopefully this draft shield will be enough. Yes, it is made of plywood. Work with me, it's what we had available at the time. I do, of course, have a fire extinguisher handy in case things do go nuclear, and I'm kind of hoping that they do. And if they do, we'll rip the panels down. They're only held in with a little bit of masking tape, okay? It's what we need to do to keep it from potentially lighting my house on fire. So we're gonna work with it this way. Now, what we're expecting to see here is quite a bit of heat come from this hot end very, very fast. You're running about a 30-watt cartridge here, and well, that is enough to melt aluminum given enough time. Thermal Runaway is the protection circuit that exists for when your printer is heating and heating and heating, but the thermistor, which of course is not in the heat block of this printer, does not recognize that something has changed. When that does occur, the printer says, yo, this is not good, I'm gonna stop. Except not all printers do that, and this is one that doesn't. Now, thankfully, this printer has had a very rough life. It was recently dropped by the individual that owned it, and it is, yeah, it's not salvageable. It's not worth it because it's not safe. But let's let this thing heat up. We got a tight camera pulled in as well, so we can watch the carnage as it unfolds. Now, unfortunately, we don't have a FLIR camera, so I'm not really able to give you guys an idea of how hot it is, other than you definitely don't want to touch it. It's too hot to trot, if you will. But it's not too hot for this segue to our sponsor, 3D Musketeers. If you are looking to demystify the 3D printing process, to make things easier, safer, and more enjoyable, the pros over at 3D Musketeers can help you get your ideas out of your head and into your hands by utilizing awesome technology. Nothing like this. This is old, this is crappy, and this is dangerous. It's garbage. It's quite literally garbage. Our printers go through a rigorous set of tests before we ever allow them to be used for personal or client projects. But that's the beauty of what we do here. We have almost 40 3D printers to help you make awesome. This is not on the list, don't worry. But with over 30 years of combined experience in this industry, the pros at 3D Musketeers can help you make awesome every single day. And with almost 40 3D printers, it makes that process quite a bit easier, even if you do have the odd failure or two. If you want to get some assistance from the pros at 3D Musketeers, you can hit us up at the links in the description down below or at all the social media links right there on your screen. But enough about that. I think we're getting a little bit toasty. I'm getting the smell of burning plastic. I'm excited. Let's watch. Now, even though we don't have a FLIR camera, we can use the dead leaf of science here, and we can measure how hot this is. If it's quite hot, it's going to go ahead and just burn the leaf. And yeah, that's the definition of really, really hot. That means this thing is continuing to heat. I'm not seeing Thermal Runaway triggered on the printer, and considering that it ran for an hour
like this beforehand, I know for a fact it's not going to stop. We're gonna let this thing keep going. We'll come back when something cool happens. Okay. So on its own, this one probably isn't going to catch fire. Not anytime soon. So let's put it into a condition where it might make a little bit more sense. I'm not gonna set it to print, that's ridiculous. That's danger to all things involved. But let's try to feed some filament into it and see what happens. I've got some atomic PLA because apparently I'm only going to feed dangerous printers the good stuff. We'll hang it up here just for good measure because I'm a jerk and that's just what feels like the right motion. But I can tell you this thing is really hot because as soon as we try to put filament into it, oh God, I can feel the whole thing is warm. As soon as you try to put filament into it, look at that. This is the problem, ladies and gentlemen. That's dangerous. And see, if that is your printer, we've got a problem. Also, this is what wet filament sounds like. That is so hot, it is instantly boiling the filament. I hate the smell of burning PLA, but it's better than other filaments. You can also see the crazy amount of dye swell that happens on materials when that happens. So we fed some material through and it just said absolutely not. But we can see that this thing is the definition of stupid hot. But what does this actually mean? Unfortunately, not a whole lot. I believe we could leave this thing out here all day. But because of how it's designed, there's metal here for the bracket, even the bearings are metal as well. I think all of that plays a role in allowing it to sink away the heat faster than we can put it in. But I know you didn't click on this video to have an anticlimactic ending, so let's fix all that. Yes, this isn't indicative of how a regular thermal runaway scenario might go. But it's also not that far off. When you look at a hot end for a Creality printer, for even an E3D V6, if thermal runaway isn't on there and your hot end cooling fan fails, you're going to be sitting there with just a big chunk of metal that's going to get very, very hot. There's some danger here. This heater can get hot enough to melt, theoretically, the aluminum. Now, I've never seen that happen myself, so I'm hoping that we get to see it here together. That'd be fun, wouldn't it? When we look at an instance like Tim from DeWitt 3D had, this is actually getting some assistance. In his case, the heat break actually broke in half, causing the heat block and the heater to be dragging around the print bed itself. This large block of aluminum is certainly helping remove some of that heat from the hot end itself. What we've done is by flipping it over, because heat rises, we should be able to concentrate some of the heat up toward the nozzle, which is starting to turn blue, which is quite interesting. That might have been from the filament. I'm honestly not certain. Now remember, you might think, Grant, this is taking too damn long, where's the fire? Well, remember, it's gonna take a long time to get this thing as hot as it needs to be. And the fire realistically doesn't come from the actual printer. It comes from the heat block melting, touching the plastic and whatever that build surface is made out of. And then it comes from the heater itself starting to turn cherry red and then eventually white hot. That's gonna take some time on a printer like this. On DeWitt, it took about 11 minutes, but that thing had a lot less metal in it than this does. And I think its heater was more powerful. I'm not certain we're running more than about 20 watts through this heater right now, because even a 30-watt heater would have melted aluminum by now. So what has all of this taught us? Well, I'm gonna have to cheat if I want to get fire. And that, at least on this printer, the hot end heater is not enough to melt the heat block. It's also going to produce a lot of smoke if you're working on filament during this. So if you're actively printing and your printer goes into thermal runaway, you're going to come back to a house full of smoke. But thermal runaway isn't something that should happen anymore. Again, this printer is bone stock. I think, at least on the firmware side, it's bone stock. At least this printer is safe. The ANET A8, the printer that is kind of famous for catching fire and burning down homes, and even the printer that DeWitt, Tim, will link to his channel down below as well, we're dealing with, were all made of acrylic. They were all made of plastic. This thing, even though it's built to a price, is still made out of metal. And that metal is, well, working to its favor right now. I'm feeling diabolical, and I know a lot of you are too. Warning, do not try what I am about to do at home. This is stupid under any circumstances. This is alcohol in a spray bottle. Wow. Nothing. Well, that's upsetting. Maybe we should have done some research before doing that. The auto ignition temperature of isopropyl alcohol is 399 degrees centigrade, which I don't think that is at. And aluminum, or aluminium, melts at well over 600 degrees centigrade. And quite frankly, I don't think this heater is going to get there. I think it's too tiny. And we could go about it the nice way, or I could just go inside and get my blowtorch. I think we all know what I'm going to do. Oh, I got the block melting. Oh yeah, the block's melting. Has the heater failed out yet? Nope, the heater has not failed out yet. That is crazy. That is honestly crazy how fast that worked. That's pretty cool. Well, it's very hot, but you get what I'm saying. And I know, we had to cheat. Yell at me in the comments or something. Oh yeah, no, the heater's still heating. Holy shit, yep. That's what I wanted the first time. Well, the heater's still heating. So through all of that, the heater is actually still there. It's still on. And we can see this because it instantly ignites ABS. Bless it. Oh, that's on fire, isn't it? Yep. Get. Now we're going into total and absolute destruction. So here's what we're gonna do. We're gonna use some ABS. We're gonna get it a little bit toasty here. Since ABS is oil-based, it should burn quite well for a while here. I'm just laughing that even the raw heater is not turning white hot. But I think that's just because this heater is really just not well made. Nah, not my smartest move. All right, we got a little fire going, I guess. Yeah, might want to take the propane torch away from that. But this is why you don't want fires on your 3D printer. It's not good. Let's get the highly flammable roll of ABS off it. You know, let's not. La 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 la, just watering my printer, except the water is actually isopropyl alcohol. And yes, I'm cheating, but I hate this printer and I don't want anybody else to ever be able to use it again. So I'm making sure of that. It's the right thing to do. There it is. That's a lot more fun. Come on. Come on. There it is. All right, the spool's caught. That is, that's very much on fire. I'm letting it burn. I'm gonna let this whole thing burn. Oh God. All right, so maybe I cheated just a little bit, but there you go. It's definitely a roll of ABS. There you go. That's what Thermal Runaway looks like. Thankfully, modern printers don't have this problem, and we don't have to worry about it too much, but it's hot. It's hot. Now that we clearly have a pretty decent fire going, I've always wanted to try these, and I figure I'm not the only one. Let's get the bottle of alcohol away. And let's see, this is an easy fire spray. It's a fire extinguisher, so let's see if it works. Oh, damn. Okay. It's like killing wasps, but it's fire. Oh, it doesn't like oil. I'm going to give it credit. That's actually really, really well. Here we go. There you go. Can confirm. These fire extinguishers actually work great. But that's really boring. Now, is this realistic? Well, no, it's not. It's not realistic at all. This is clearly accelerant that we've applied to it. But if your printer is made of plastic, if it is an acrylic printer, this is actually possible.
So, what did we learn here? Well, ultimately, Thermal Runaway may not actually cause your printer to melt down. If you have an entire metal frame 3D printer, it's likely going to wick the heat into that. And you saw that I had to physically pull it off and do quite a few things before it even got to a point where it could set ABS on fire. What we've learned, though, is that that printer only draws 36 watts during Thermal Runaway. That means the entire motherboard, power supply, fans, and the heater are collectively combined, drawing 36 watts. Your average 3D printer heater is 30 watts, and I promise you that there is a lot more than that lost in inefficiencies here. Maybe that's not 100% indicative of what you might see with a modern day 3D printer. If you guys want to see us test it on modern hot ends, let me know. We can build a test rig for this, but I want to go through this, right? This video might tell you, oh, it's not something I have to worry about. And in fact, people that I showed some photos to said, so you're saying Thermal Runaway is not as big of a problem as we all think it is? No, it absolutely is. On that particular printer, it was not. And that does not mean that your printer will be the same. The ANET A8, and most recently, the printer that Tim from DWIT 3D reviewed, absolutely had enough heat to catch fire. Ultimately, if it doesn't burn your house down, it's at least going to make a hell of a mess, and that smoke is going to be something that permeates into every fiber in your house. So what I'm saying is, in this particular case, yeah, we cheated a little bit, and we were very clear about that we cheated. But that meltdown that you saw is absolutely real. That can happen. Filament can catch fire. Your printer can catch fire if it does not have the safety features. If you want to check if your printer does, it's very simple. Take your thermistor and pull it out of your hot end, then go ahead and tell the printer to heat. Give it about a minute. If after a minute it has not shut itself down, you likely have a Thermal Runaway problem. You can wait a little bit longer if you want, but make sure you watch it because it is very easy to have this thing become an issue. Now, we also tested this outside. Outside in Florida, there was a little bit of a breeze. We did our best to take care of it, but it's not indicative of what it would be inside of a home. And testing it and making sure that your printer is okay is vital to making sure that you're going to have a good 3D printing experience.
Now, for all you insurance people that are out there looking at this video saying, ah, 3D printers are dangerous. They're not dangerous. I literally had to set this thing on fire. We left it in Thermal Runaway for over 2 hours today, and it never caught fire. I did everything that I could to try to make it catch fire, and ultimately it was alcohol and propane that made it catch fire. That's all I gotta say about that. Look, if you guys want to see more about this topic, let me know. It's very easy for us to test Thermal Runaway. All you really have to do is hook up a heater to a power supply. But I wanted to show what it looks like from a printer perspective and why it is a bit of a bigger deal than you might initially think. Now, this printer is complete and utter trash. It was complete and utter trash when we started as well. I've just assisted it in returning once to where it came from. That's really all that I have for you. Let me know down in those comments what you think about this. I know we kind of went crazy here at the end, but it was worth it. We both know it was worth it. And yes, I'm far enough back. I can't even smell the smoke at this point. But that's all that I have for you guys today. Leave a comment down below. Let me know what you think of the forbidden chocolate pudding. Stay safe out there. Don't forget to call your loved ones. And as always, keep a fire extinguisher handy. Have a good one. Our videos are literally fire! We gotta do a field reload. Reload! Fire! Hello. Do you guys want to help film a video today? Huh? Head scratches for everybody? How about you? You want some head scratches? How about a little nose scratch? You want a head scratch? There's one for you. Thank you guys for being the extras in the video today. Oh, yeah. Oh, yep. You like that too. Hey, thanks so much for watching this video, and a massive thank you goes out to all of our Patreon and YouTube channel member supporters whose names are listed right next to me at the $5 tier and higher. If you're looking for something else to watch, right below me will be the entire printer maintenance series, where you can also be checking for Thermal Runaway. And next to that will be a random video. Hopefully it's one that you like. Click on it. Let me know what you think in those comments. I'll see you guys in the next one, and in those comments, take care.